All right, today we're starting the topic of absolute value functions. I have here graphed the parent function of the absolute value. The way you write absolute value notation is these vertical bars right here. They mean absolute value. All right. When you type in the equation into Desmos over here, there's no such thing as the bars. It doesn't allow you to do that. So what you have to do is type ABS, abbreviation for absolute value. Okay, so this equation right here and this equation right here mean the exact same thing. It's just a different way of writing it in the Desmos language. Okay, all right, so we've studied transformations before, so now we're going to study transformations of this absolute value parent function. Okay, as you can see, the parent function, its vertex is at 0, 0, and then it's identical on the left and right. It has opposite slopes. So like this slope on the right is going to be 1 because it goes up 1, right 1, up 1, right 1, up 1, right 1. The slope on the left side is going to be negative 1 because it goes up 1, left 1, up 1, left 1, up 1, left 1. Okay? All right. So let's see what happens here when I change these parameters A, H, and K here. So when I put a number in front outside the parentheses, remember that was a vertical stretch or compression. Let's see if the same thing happens here as I change A and see if it is a vertical stretch or compression. You can see there's negative values too, just like when we did the transformations. When you multiply by a negative number, it reflects it. So if A is negative, it's going to reflect it over. It's going to open downward. We say that. Let me get it back to positive values. All right, let me slide it myself now. All right. So if A is 2, you can see it got vertically stretched by 2. Another way of thinking about that is A is always going to be equal to whatever the slope of the right side of the graph is. So like here, start here, up 2, right 1, up 2, right 1. The slope is going to be 2. If I change this to 3, up 3, right 1, up 3, right 1. Okay, the slope A is going to be the slope of the right side of the graph. All right, so what would be the slope of the left side? If A is 3, the slope of the left side is going to be negative 3. The left and right sides always have opposite slopes. One's positive, one's negative. Okay, and let's go over an example again. If A were negative, let's just say A was negative 1. All that does is flip the graph over the x-axis. The slope of the right side is negative 1 because it goes down 1, right 1, down 1, right 1. The slope of the left side would be positive 1. Okay? So A just acts just like the same as when we did vertical stretches and compressions. All right, let me reset the A back to 1. All right, so what about H and K? Those are you're adding and subtracting, so that's going to be a translation, just like we did with the transformations unit. All right, so look what happens when you move H. That causes the graph to move left to right, the exact same way we did when we did transformations. Okay? Notice, here, let's say H is 2. What's this X value of this vertex? 2. H is 3. The vertex is at 3. H is 4. Vertex is at 4. Okay? What if H happens to be negative 3? Vertex is at negative 3. So the addition and subtraction here acts just like the translations we did in the previous unit. All right, no big deal. All right, what happens if we change K then? If I add or subtract the number outside the parentheses, that should move it up and down. And it is. Okay. Notice the y value of the vertex. Let's say K is negative 4. It means we moved the graph down for us. The vertex got moved down, so the vertex is at negative 4. Okay. That's the basics of the parent function for the absolute value. Let me reset these again. Just remember, A vertical stretches and compresses and reflects. H moves it left to right. K moves it up and down. So like if I stopped it right there, I know that the vertex is going to be at -3, -1. Let's check it. -3, -1. Vertex is there. All right. And I know that A is 2. That's a positive number. So it's going to open up. It's going to be a V. And the slope is going to be 2 on the right side and -2 on the left side. So if I wanted to plot this out and I had the vertex, I would go up 2, right 1, up 2, right 1, up 2, right 1. And then to get the other side of the graph, I would go up 2, left 1, up 2, left 1, up 2, left 1, and just repeat the process. And I'd have the graph of the absolute value function for those transformations. I have some more examples worked out on the Google Doc that I shared with y'all in the Google Classroom. So look at those and be ready for class tomorrow. I'll see you later.